Okay, so for this one, let's do... I'll put some arrowheads on this one. Call that point A. Call that point B. So what is A and what is B in terms of relative versus absolute maxes or mins? So take a minute and try and reason that out. What do we got? Okay, so what's A? It's a relative min. And what's B? And that's a relative max. So, there is no absolute max, right? There is no absolute min. Okay? Now, technically, yeah, you could say, well, you wouldn't be right, but I get why you're saying. The relative max is infinity. The relative min is negative infinity. Yeah, but you can't ever actually get to infinity, right? So maximums and minimums are points. Infinity is not a point. You can't get there. So you just say it has none. Okay, there is no maximum. There is no minimum. All right, with those arrowheads, we know it would just keep going up, just keep going down. Okay. Now, if these points, if we had coordinates for these, because they might ask you to do this too. So let's say this is at 1. This is at -1. Maybe this is at -2. This is at 1. So they might ask you, what is the value of the relative min? What's the value of the relative max? When they use the word value, are they talking x or y, do you think? Y. The y is the value of the function. X is kind of like where it happens. And the y is kind of like what you get from where it happens. That input-output idea we talked about with functions, okay? A value of a function is an output of a function. So the y's are the values, okay? So what is the value of the min? Whoops. So the value of the min is -1. And the value of the max is +1, okay? Or they might ask you, what are the coordinates of the min? What are the coordinates of the max? Okay? So in that case, you'd give them the ordered pair, okay? So you got to pay close attention to how exactly they're asking the question, too, okay, as to what kind of information you're going to give them. Make sure you don't give too much or too little, depending on what that is. But, okay, so that's the extrema stuff. Let's see, so we've hit both of those. So bounds of functions. Okay. This is actually pretty easy. All right. So this refers to the y values in a function. So I'm just going to draw you some quick little pictures here, and I think it'll pretty much explain itself. But if a function is what's called bounded above, that means that there is a certain point at which a function stops growing or doesn't go above. So if I had a function that looked kind of like this, like a parabola opening down, if I draw some line above the function that it never crosses above the function, we say it's bounded above then. So that type of function would be bounded above. Bounded below, it's exactly the same thing, except I could put a line, a horizontal line below it. that it would never cross. So that would look something like maybe I had a function that had a couple little terms in it, but it's not going to go below some kind of imaginary line in the sand down there. Okay, so we have certain functions that are bounded above, certain functions that are bounded below. There are other functions that are what we call just bounded, which means they've got both things going on at the same time. And these are pretty rare. But can you guys think of any functions that you've looked at before that we would call just bounded? Sine wave, good. Yep. So those types that just kind of keep going like that. So we could have a bounded above and a bounded below happening all at the same time. So in that case, it's just bounded. And then there's a fourth case, which is where it's not bounded above or bounded below. And for those, we just call them unbounded. Okay? So I'm actually going to come up here so I don't have to go on to the next page. Bless you. Okay, so unbounded would look something like this, maybe. Are you serious? Pencil, come on. All right, so something like that, okay? I can't put a line in the sand above it or below it. That's never going to go above or below. It just keeps going both directions. It's unbounded, okay? So we're going to come back to this. I remember I said next week you guys are going to be investigating individual functions and then kind of doing little mini presentations on those. So you're going to have to identify the function that you're looking at. Is it bounded above, bounded below, bounded, unbounded, based on the shape of the graph? What do you have going on? Okay? So I'm just going to leave that there. And like I said, we'll investigate that stuff a little further with all of that. But that's what that stuff means, okay? And then finally, talk about some asymptotes. All right. Now, vertical asymptotes these are created, if you remember from Algebra 2, these are created when they're places where, or they're numbers that would cause the function to divide by 0. So, values of x so basically, I guess in general, they're values of x that caused the function to be undefined. Because of dividing by 0. So I guess a good example of that would be like f of x equals 1 over x. Okay? This particular function has a vertical asymptote. What value of x is going to cause this to be dividing by 0? 0. So this has a vertical asymptote at x equals 0. Okay, so if you're given a function, you're asked to identify all of the vertical asymptotes. That's what you're going to be doing. It's just thinking about looking at the equation and what numbers, if I plug them in, are going to make it divide by 0. All right, so let's do a couple more examples of that and see if you guys can come up with them. So for each of these, just tell me what are the vertical asymptotes. All right, so I'm going to try those three. The nice thing about this is you only need to worry about the denominator, because that's the only thing that's going to affect whether this is going to divide by 0, right? So I can put whatever craziness I want in the numerator, and it's not going to affect where your vertical asymptotes are. So think of it that way. Just look at those denominators. Where are the vertical asymptotes for each of these? All right. I'd like to give us the first one. 2 over x plus 3. Where's the vertical asymptote? Yeah. -3. Good. All right. Second one. 4. And the last one? 1/2. Yep. Good. Okay. So, like I said, you can kind of ignore what's in the numerator. Just look at the denominator. Pretty straightforward. And a lot of times they're not going to have vertical asymptotes at all. If there's no fraction in the equation where there's x in the denominator, then it doesn't have one, and you're good. So just be aware of that too. Are not too crazy. Horizontal ones